Okay, imagine you've built this huge, super intricate Rube Goldberg machine. One thing knocks over another, which triggers something else. Hundreds of tiny parts all working together.
Right, a complex chain reaction.
Exactly. Now, picture something goes wrong. Not a big, obvious broken gear, but maybe a tiny spring deep inside is just a fraction of a second too slow.
Hmm.
And it makes the final step kind of unreliable. Sometimes it works, sometimes it just fizzles. You can see it's not quite right. But where do you even start looking for that tiny glitch?
Yeah, that sounds frustratingly familiar for anyone working with complex systems.
Well, that's pretty much the world of modern software, especially microservices. And today, we're going to dive into the solution. Think of it like an amazing GPS tracker built just for a user's request navigating this digital maze.
That's a great way to put it.
We're talking about distributed tracing in microservices. And our mission today is to unpack what it is, why it's, well, absolutely essential now, and look at the key tools that actually make it happen. It's about getting real answers, not just guessing.
Absolutely. And it's fascinating how applications have changed. We've mostly moved away from those single giant applications monoliths towards microservices.
Right.
So breaking things down into smaller independent services.
Mm.
Each one does a specific job, maybe user login or inventory checks or payments. And they all talk to each other over the network, usually with APIs.
So instead of one big machine, it's like hundreds of little specialized machines all chatting constantly.
Yeah.
Sounds flexible, yeah, but I can see the problem. If one request involves, say, 10 or 20 of these services, how on earth do you debug that? If something slows down, how do you find the lazy machine in the chain?
That is precisely the challenge.
Mm.
A single click, like add to cart, might kick off a whole sequence across many services.
Right.
Without a way to follow that specific request all the way through, finding the root cause of a delay or an error. It's like trying to find one specific faulty wire in a massive tangled switchboard.
Yeah.
Distributed tracing is the method designed to solve exactly this. It lets you track and monitor that request's entire journey. You see the exact path it took, how much time it spent in each service, and crucially, if anything went wrong along the way.
Okay, so back to the GPS tracker idea. If I click place order online, that starts a trace. What does that actually look like? What are we seeing?
Exactly. So placing an order. The request might first go to a user service to check who you are, then maybe to a product service for inventory,
Okay.
and finally a payment service. Each of these specific actions, like check inventory within the product service, is recorded as a span.
A span. Got it.
Yeah, and the really smart part is how these spans get linked together. They use unique IDs that travel with the request from service to service. That's called context propagation.
Ah.
This lets the tracing system build that complete trace view. It shows the whole journey, click to confirmation, every hop, how long each took. It's a timeline, basically.
So it's more than just logs. Logs tell you what happened in one place, but this tells you the story of the request across all the places.
And the timing.
Precisely. It's about the relationship, the sequence, and the timing between all these distributed steps. It is, well, invaluable for actually understanding what's going on inside these complex systems.
Yeah, I can see that. Moving beyond just guessing.
Definitely. It lets developers see exactly how services are interacting and pinpoint where things are going wrong or slowing down.
Which leads us nicely into why this is so important. It's not just a fancy debugging tool, right? You're
No.
saying it's fundamental now.
It really is. It's become a critical part of what we call observability. Because distributed systems, by their very nature, are just hard to understand without this kind of tracing insight.
Right. So that example. A customer complains about a slow checkout. My first guess might be, I don't know, the payment processor, maybe the network itself, but that's just a guess. And tracing takes the guesswork out. If that buy now click triggers 5 services and it's slow, tracing shows you the exact path and the time spent at each stop. You might find, oh, look, the payment service itself is fine, but it called out to this external tax calculator, and that took 3 seconds.
So it could be something completely unexpected.
Very often. That's what's so powerful. It often reveals the bottleneck isn't where anyone suspected. It might totally change your understanding of how things are connected, maybe uncovering some hidden dependency, or even just a database query that's milliseconds too slow but happens millions of times. It just cuts down troubleshooting time dramatically.
I remember a time, actually, we had this weird issue, orders failing sometimes. We spent ages looking at the main order service logs.
Yeah.
Turned out, tracing showed it was a tiny, almost forgotten internal address validation service timing out occasionally. Would have never found it otherwise.
That's a perfect example. Saves you chasing ghosts for weeks. So yeah, it's not just for fixing things when they break. It's about performance monitoring, too.
Proactive optimization, you mean?
Exactly. Tracing clearly shows how long each microservice is taking. You can spot those consistent slowpokes or maybe an external API call that adds up over time. Find them, optimize them, improve the user experience.
Makes sense. And when errors do occur, because they always will,
Yeah, inevitably.
tracing must be a lifesaver then.
Totally. If a request fails, tracing usually points right to where and why, like error in inventory service. Couldn't connect to database. You see the context. Saves hours, maybe days, of digging through logs across multiple systems.
Okay. And you mentioned dependencies earlier. How does tracing help with that?
Well, microservices don't live in isolation, right? The order service needs the payment service, which might need an anti-fraud service, and so on.
Right, they rely on each other.
Tracing automatically maps out these call chains, these dependencies. Just by looking at the traces, you see who calls whom. This is vital for understanding the impact of changes. If you update the payment service, what else might be affected? Tracing helps you see that. Sometimes it even shows dependencies you didn't know existed.
Okay, so troubleshooting, performance tuning, error finding, understanding dependencies. It all seems to point towards one main goal for the business, doesn't it?
Absolutely. It all comes down to a better user experience and more reliable systems.
Happier users, basically.
Happier users, more trust, better efficiency. When you can quickly find and fix problems, the application runs smoother. Tracing provides that feedback loop you need to keep these complex distributed systems healthy and performing well.
So we need tools to actually do this, to collect and show us these traces.
Yes, exactly. We need specialized tools to implement tracing. They collect all that span data, piece it together into traces, and give us a way to visualize it all. They're like the control center for understanding your system.
Right, makes sense. So how do we actually see this data? What are some of the main tools people use? Maybe start with Jaeger. What's that?
Sure, Jaeger is a really popular open source tool specifically built for distributed tracing. Its job is to track requests and let you visualize them.
How does it work, practically?
Well, you typically add some instrumentation to your microservices, maybe using a library or a small agent. These send the tracing data, those spans we talked about, to Jaeger collectors.
Okay.
Jaeger then assembles these spans into the full traces, and developers use its web UI to see these traces as timelines, filter them by service or errors, and spot those delays. It supports key standards like open tracing and now open telemetry, which is important for avoiding vendor lock-in.
And why is it so popular, especially, say, in the Kubernetes world?
Several reasons. It's known for being quite developer-friendly. It's completely free, open source, and it's widely used, so there's good community support. Plus, it integrates nicely with common frameworks like Spring Boot and works well in cloud-native setups like Kubernetes. And honestly, the visualizations are just very clear. It makes complex flows easier to grasp.
Okay, so Jaeger sounds like a solid open source choice. What about Zipkin? Is that similar or different?
Yeah. Zipkin is another really well-known open source tracing tool. It works on pretty much the same principle as Jaeger. You instrument your services, they send span data to Zipkin, and Zipkin provides a UI to visualize the trace timelines. You can filter traces, analyze durations, find errors, very similar core features.
So if they're similar, why choose one over the other? Is it just preference?
Sometimes it is preference, yeah.
Hmm?
But Zipkin is often mentioned as being perhaps a bit simpler to set up initially, maybe a bit more lightweight.
Oh, okay.
So for smaller systems or teams wanting something really quick to get going, Zipkin can be a great choice. It also has a very strong, mature community. Both are good options, really.
Mm.
Sometimes the choice comes down to which one has better library support for the specific programming language you're using.
Gotcha. Okay, so those are two big open source players.
Yeah.
What if you're heavily invested in a cloud platform like AWS or Google Cloud? Do they have their own tracing tools?
Oh, absolutely. The major cloud providers have their own integrated tracing services.
Yeah.
AWS X-Ray is a big one, and Google Cloud Trace is another prominent example.
And how do they work? Are they easier to set up since they're part of the cloud platform, more plug and play?
They're definitely designed for convenience within their ecosystem. Often, they can automatically collect tracing data from services running in their cloud, especially managed services like AWS Lambda or Google Kubernetes Engine.
Right. Less manual setup, maybe?
Potentially, yes. They provide dashboards for viewing traces, filtering, finding issues, just like Jaeger or Zipkin. But a key benefit is that the cloud provider manages all the backend infrastructure for the tracing system, the collectors, storage, UI. You don't have to run it yourself.
Ah, that could be a huge advantage for some teams. Less operational burden.
Exactly. If you're already deep in AWS or GCP, using their tracing service can be very appealing. Minimal setup, seamless integration with other cloud services you're using, like logging or metrics. It makes them pretty beginner-friendly from an operations perspective, though you still generally need to instrument your application code itself to send the trace data. So yeah, whether you choose an open source tool like Jaeger or Zipkin for that flexibility and community, or a cloud provider tool like X-Ray or CloudTrace for the convenience and integration, they all aim for the same goal.
Right.
They help you trace requests across your application's microservices, what we call app-wise tracing. And crucially, they all give you those visual dashboards to make sense of what can be really complex request paths, turning confusion into a clear map.
So that's quite a journey we've taken. We started with that Rube Goldberg machine problem, the complexity of microservices. Then we defined distributed tracing, explored why it's so necessary, not just nice, but necessary, and finally looked at some key tools like Jaeger, Zipkin, and the cloud options that make it real.
Yeah, and hopefully you listening feel like you've got a much clearer picture now. It's a really critical area in modern software, and understanding it gives you a big advantage. It moves you past just knowing the buzzwords.
Definitely. So here's something to think about as we wrap up. We've talked a lot about how tracing helps you fix problems reactively. But what if having this deep insight into how your system actually behaves where the real bottlenecks are, where those hidden dependencies lie? What if that could fundamentally change how you design your next generation of microservices?
Interesting thought.
Could knowing exactly where things tend to go wrong or slow down allow you to architect systems that are inherently more resilient, more efficient, maybe even cheaper to run right from the start? Think about that shift from reactive debugging to truly proactive, insight-driven design. That's maybe the deeper power of tracing.